Hi, this is video 2 for chapter 5. So it's kind of a continuation of section 5.1. There's a lot in this section. But in this video, we're going to cover picking a better buy and then comparing rates. So finding rates and then comparing which one is faster. So first topic, better buy. So what does it mean when we say pick a better buy? When I say better buy, that means pick the cheaper option. So better buy is always going to be the cheaper choice, right? So when you go to Meijer, you could either buy Meijer brand things, or you can buy like Kellogg cereal or a name brand thing. And usually you can compare those two prices and pick which one is cheaper. So we're going to learn how to do that in this section. And that's something that you'll actually use the rest of your life. Every time you go shopping now, you can pick the better buy. So when you find a better buy, you're always going to set it up as money on top. So this is going to be the price or the cost on top divided by the items that you're buying. So some examples, you might find like the price per ounce or the price per pound or the price per cup or the price per can. So you're always going to have money on top divided by what you're buying. So let's look at this example. You want to buy some CDs, right, for Christmas gifts or whatever. So you have two options. You can go to this store, Music City, and they have a deal going on where it's 5 CDs for $49.95. Or you can go to this store, CD World, and their deal is 7 CDs for $65.80. So you want to go wherever the CDs are cheaper. Okay, so we said we always put money on top. So I'm going to set these up where I'm going to find the rate, the cost per CD at both of these stores. So for the first one, money on top would be $49.95 divided by 5 CDs. And at the other store, it is $65.80 divided by 7 CDs, right? So in both cases, I have money divided by CDs and money divided by CDs, and this will give me the cost per CD, right? When I divide these, this will give me the cost per CD. So let me give it a little bit more room, and let's actually divide these and see what we get. Okay, so I divided this first one and I got $9.90 per CD, so $9.90 for each CD. And at this one, it comes out to 9.4. Well, in terms of money, that would be $9.40 per CD. So if I was picking at which store I want to go shopping where the CDs are cheaper, they're obviously cheaper here. I'm picking the smaller cost per CD. $9.40 per CD is cheaper than $9.90 per CD. So that's what we mean when we say pick the better buy. They would be cheaper at CD World. So we'll do a few more examples of those, but first I want to talk about kind of what these numbers would mean in terms of money. If you're doing a problem in terms of dollars and you get these decimals on your calculator, what do they really mean and how should you label them? Okay, well, if you're doing a problem in terms of money and you get this, we know that looks like a normal price. That would be 3 cents. Okay, I could also write it on my paper like this, 3 cents. But you have to keep it straight. When do we use a dollar sign and write it like this as a decimal? And when do you just turn it into whole cents, but then use the cent sign? Okay? Or this next one. If I ended up with this number on my calculator, that looks kind of funny in terms of dollars, but I can tell that that actually means, right, if I kind of move it over to look at cents here, this would be half of a cent. So when you're finding better buy prices and price per ounce and price per gallon and things, you're going to end up with like parts of pennies. So this is half of a cent. I could write it like that, half of a penny. Or this one, we all know that looks like normal money, $1.76, or nobody would write it this way, but that's the same as 176 pennies, right? 176 cents. This one looks pretty good. That's just 85 cents, or I could write it 85 cents. Or this one looks a little bit funny in terms of money, but we know that it would be the same if I added that 0 there. And then we can tell it's just 20 cents, right? So you could write it either of those two ways. Okay, the point is you just can't write it this way and have it mean the same thing. That would be something totally different. So if you mean 20 cents, you either have to write it as $0.2 or 20 cents. Don't mix and match the number you mean with the correct symbol, okay? Or this one, again, put my dollar sign there if I get this on my calculator. That looks a little funny in terms of money or prices, but you might get an answer like this for one of these problems. So this is the same as 7.4 cents, right? So not quite, a little bit more than 7 cents, but not quite 8 cents. So it's really careful that you kind of understand what these mean in terms of money and that you label it correctly with either a dollar sign or a cent sign, right? And that you're able to compare and kind of pick even if it goes into maybe 3 or 4 decimal places. All right, so which is the better buy? Here's 2 examples that we'll do together, and then you've got 2 to do on your own. So remember, put this hint on your paper if you need to. Always do money on top divided by the items or however many things you're buying. Okay? So when you do these, you cannot just look at it and guess. You can't just try one of them and then decide. You have to actually set both options up and divide them, and then you can compare once you get your answers. So which is the better buy? 5 calculators for $105 or 24 calculators for $552? If I want to pick which one is cheaper per calculator. Okay? Well, money on top, let's do the first option. $105 for 5 calculators. Okay, and then the second option, make sure I read it carefully and put money on top again. $552 for 24 calculators. Now, I want to point something out. I didn't just take the numbers in the order they were written. I didn't just take 5 and 105 and then 24 and 552 and put them the same way. I made sure to put money on top of calculators. Money on top of calculators. Okay. The other important thing is everything has a label. I have dollar signs and I have calculators labeled when I set it up. That's really important. So let's divide these and see what we get. Type them into your calculator. Okay, there's my answers when I divide, but I still need labels, right? This is dollars per calculator and dollars per calculator. So if I want to pick which one is cheaper, would you rather pay $21 for each calculator or $23 for each calculator? Probably this one. You're always going to pick the cheaper option, the lower price per calculator. Okay? All right, so we've got one more to do together here. 72 ounces for $92.50 or $62.40 for 48 ounces of something. All right, so let's set them up. Remember what goes on top. Money divided by ounces, and everything gets a label. Money divided by ounces, and everything gets a label. So go ahead and type those in, divide them, and let's see what comes out as the cheaper option. All right, again, I divided it, but I still need labels. This is dollars per ounce and dollars per ounce. Let's pick which one's better, $1.28 per ounce or $1.30 per ounce. This one's cheaper, so that's the better buy. Okay, so we did 2 together. Now you have 2 to try. So the next 2 look like this. Pick which one is the better buy. So set them both up, divide them both, and then decide which one would be the better option if you were buying these. So pause, and then we'll check together. Okay, here I've just set it up and I made sure I always put money on top of, in the first one, how many pieces of candy. In the second one, money divided by ounces. It doesn't really matter what this label is. As long as money's on top, you're finding the cost per item, and you do them all the same way, then you'll be good. So let me divide these and then we'll pick. So pause again, make sure you've got them divided to find the unit rates. Okay, so I divided and this is what it looks like, but let's talk about these just a little bit more. In this first one, you can see that it says 16 cents per piece of candy and 16 cents per piece of candy. So we need to look a little bit further before we can pick which one is better. If you go back to your calculator, this one actually says 0.1605 and this one just says 0.16. Okay, so now if I look at more decimal places, I can actually pick which one's cheaper, right? If my decimal ends here, that means there's really a 0. It would just keep going in zeros. So now I'm comparing which is cheaper, 1605 or 1600. And now we can tell that the one that ends in 5 is a little bit bigger, so this one would be cheaper. So when you get numbers that look really close on your calculator, you need to look further at more decimal places so you can actually pick which one is smaller or cheaper. And in the next one, I wrote down, these are the answers I got on my calculator, right? From here, I can tell this is 24 cents per ounce, and this one would be 22 cents per ounce. So again, this one's cheaper, all right? So fill these in on your paper. When you're finding a better buy, there's two things that you need to make sure you always do. First one, and you're going to fill these blanks in. Always do money divided by the items. Always do money on top divided by items, whatever you're buying. Ounces, pounds, cans, boxes, whatever. But money on top. And the second thing, make sure you always pick the smaller number, the one that's cheaper, the one that's a lower cost. People get confused and they go too quickly and they think the bigger number is better. Well, it's not better if you're paying more. So pick the smaller number. That means it's going to be cheaper as long as you set it up with money on top. Okay, so maybe not money problems, but we still need to just be able to compare rates in general. All sorts of rates. We need to be able to compare and pick which one is better. So here's a problem that says you do 33 homework problems in 7 minutes, or Chevy does 42 homework problems in 9 minutes, and who does their homework faster? So again, we're going to be finding the rates and then picking which one is better. So before we set this up, we need to think about which way makes more sense. Would you think about this problem, the rate that you want to find? Do you think it makes more sense to find homework problems per minute, or how many minutes it takes to do each homework problem? Now, in this case, it really could go both ways. I think probably how many problems per minute as a rate might make more sense. But what's important is that you think about it, pick the one that makes more sense to you, and then make sure you do them both the same way. So when I set that up for me and Chevy, I want to make sure that both rates are set up the same way. So if I do problems per minute, for me it would look like this. I do 33 problems in 7 minutes, and Chevy does 42 problems in 9 minutes. And as long as they match problems per minute and problems per minute, then I can divide these both and then pick. So I'm going to divide them and label them and see what I get. So pause, put them in your calculator quick. All right, so I get that I did 4.7 problems per minute and Chevy did 4.66 repeating problems per minute. And if I think about that, 4.7 problems in a minute is better, faster, more problems per minute than what Chevy got. So I'm going faster. Okay, so you need to decide which way makes more sense, set them both up, make sure they're matching, going the same way, and then find those rates and then think through which one means you're going faster, right? More problems per minute is faster. So there are 2 more problems here. Think about which way makes more sense to set up your rates, and then make sure you set them up the same way. So you're going to find the rate for Aaron and the rate for Arnold, and then pick who's jumping rope faster. Find the rate for you, find the rate for Joe, and pick who is running faster. Okay, and then we'll talk about the answers. So pause here and try both of these. Work them all the way through, label every number, find your answers, and decide who's faster. So pause and try these. Okay, so I want to stop here in the middle real quick. You probably have your work done on your paper, but I want to just talk about these. Make sure you have the same rates set up for both options, right? So Aaron, if I set this up as jumps per second, you better make sure that Arnold is also set up and labeled as jumps per second. Then when I actually divide these and find my numbers, I can compare them. Or in the next one, if I do laps per minute, I better make sure this matches as laps per minute. Then divide them and pick. So pause again if you haven't yet. Maybe finish dividing and then we'll pick. Okay. So here we go. Here's my first one. I got 2.46 jumps per second and 2.45 jumps per second. Well, more jumps, the bigger number, more jumps per second is going to be faster. Okay, what about the second one? Well, here, again, I did laps per minute, so more laps per minute right here is going to be faster. But I also wanted to point out, what if you flipped it, right? What if you found minutes per lap and minutes per lap? You could do that, but you need to think it through and realize that you want less time, smaller minutes per lap to be faster here. So